Hi everyone. Today we are going to present our topic, occupation noise exposed among fogging workers in a public health operation. This presentation is prepared for QCC 633 industrial hygiene subject uh, at Masa University. Okay, we are group 4. Uh, Consisting of 6 members, myself with Muhammad Fairuz Ibrahim, Dudizawati binti Joli, Fifi Vadila binti Aidil Patri, okay, and Shah Asfia bin Abu Bakar, Royston Chia, and Penny Anak Johnny. All right. Our presentation will focus on the issue of noise exposed among fogging workers. Okay, particularly the potential risks that workers may face during public health operation. We will discuss the source of occupation noise, uh, the possible health effect, method of assessing noise exposed, and apportion control measure to protect workers. So, without further ado, let's begin our presentation. Now, uh, let's move on the background of our topic and understand why occupation noise is an important hazard for fogging workers. Right. First, fogging machine can produce sound level ranging from opposing 85 to 120 uh, decibel with or dB uh, in bracket A. All right. Thermal and ULV fogging equipment can therefore produce noise level that may excess recommended occupational exposed limit. All right. So second, a study report uh, that 51.4% of vector control workers had noise-related hearing disorder. Right. These findings show that noise exposure can be significant occupational health concern among workers involved in fogging activities. Another important concern in a noise induced hearing loss can become uh, irre- uh, irre- irreversible. Right? Um, Once permanent damage uh, occurs to the hearing system, it cannot usually be fully restored. Therefore, early detection and prevention are very important. Fogging workers are exposed to noise because they often work close to the machine, and the exposure may be repeated during a dengue control campaign. The risk can become even higher when several machines operate at the same time, or when the sound related from building near street or enclosed area. Okay, so overall, the factors show why controlling occupational noise exposed is important to protect the hearing and long-term health of fogging workers.
Okay, before we begin, I would like to briefly explain the objective of our presentation. Our topic is occupational noise exposure among fogging workers in public health operation. The first objective is to explain what occupational noise exposure is and why it is considered a workplace hazard during fogging operation. Secondly, we want to explain why this issue is important, especially for public health workers involved in dengue vector control. Next, we will present evidence showing that prolonged exposure to loud noise can affect worker hearing and overall health. We will also discuss how noise exposure is assessed and monitored, including the health surveillance program used to detect hearing problem at an early age. And finally, we will share several practical control measures that can help reduce noise exposure and improve the safety of fogging workers. Now, let's move on to the first topic, which is understand the hazard itself. So, in this slide, I will explain the hazard that we are focusing on, which is occupational noise exposure. Noise exposure is classified as a physical hazard because excessive noise in the workplace can affect both the health and safety of workers. In simple words, a hazard is anything that has the potential to cause injury or illness. For fogging workers, the main source of noise comes from the fogging machine itself. During daily operation, they are exposed to loud noise while carrying and operating the machine for a long period. There are four main reasons why fogging workers have higher risk of noise exposure. First, the machine is carried very close to the worker body, especially near the ear. Second, fogging activity are carried out repeatedly, especially during dengue outbreak, so workers are exposed to loud noise again and again. Third is a narrow street or area surrounded by building. Sound can bounce back, making the noise even louder. And lastly, when several fogging machines are operating at the same time, the overall noise level increase and the worker receive a greater exposure. Therefore, without proper control measure, long-term exposure to excessive noise may lead to hearing problem and other health effects. That's all for my slide, and I will now hand over the presentation to my next group member. Thank you.
Good day to my honorable lecturers and to my group members. My name is Penny Anajuni. Now I'll be presenting my part, which is about the hazard sources, exposure pathway, and health outcomes of noise exposure during fogging operations. Let's start with the main sources of noise during fogging operations. There are four main sources. The first is the thermal foggers, which produce around 85 to 100 decibel of noise. Most of this noise comes from the combustion engines, the exhaust, and the moving mechanical parts inside the machines. The second source is the ULV foggers or ultra low volume foggers. It produces about 90 to 95 decibel, which is mainly because of its high-speed motor, rotating fan blades, and the pressurized spray system. The third source is the exhaust and machine's vibrations. Since the operators stand very close to the equipment, they're continuously exposed to both the loud exhaust noise and the vibrations from the machines. Lastly, the working environment also play an important role. For example, when fogging is carried out in narrow streets enclosed areas, or when several machines are operating at the same time, the sound reflects and echoes. It's making the overall noise real even higher. So, how this noise actually affects the worker? There are three main pathways. The first is airborne sounds. This is the most common route where loud noise enters through the ear canal and can damage the delicate structure in the inner ears. The second path is bone conductions. In simple terms, vibrations from the machine travel through the operator hands, body, and skull directly to the inner ear. So, even vibrations itself can contribute to hearing damage. The third pathway is environmental reverberations. This happens when sound bounces off nearby buildings or walls, especially in enclosed spaces. If several fogging machines are operating together, the combined noise becomes much louder and workers are exposed for a longer period. Now let's look at the health effects of being exposed to an excessive noise. There are two effects. One is short-term effect and the second one is a long-term effect. In term, short-term effect, workers may experience temporary hearing loss, also known as a temporary threshold shifts. They might also notice ringing in their ears, which is called tinnitus, as well as fatigue, irritability, difficulty concentrating, and even sleep problems. If this exposure continues over a long period without proper protections, it can lead to more serious health problems. The biggest concern is noise-induced hearing loss, or NIHL, which is permanent and cannot be reversed. Long-term exposure also been linked to chronic tinnitus, communications difficulty, high blood pressure, heart disease, stroke, anxiety, depression, and reduced cognitive performance. The key points to remember is that hearing damage often develops gradually, so workers may not realize there is a problem until significant damage has already occurred. That's why using proper hearing protections and controlling noise exposure are so important. So to conclude, fogging operations expose workers to high level of noise from both the equipment and the surrounding environment. By understanding where the noise comes from, how it reaches the body, and the health effect it can cause, we can take the right preventive measure to protect worker hearing and overall health. That's all from me. Thank you for listening. I'll now pass the presentations to the next presenter.
Assalamualaikum and hello my dear lecturer Miss Fatihah and my fellow friends. My name is Fifi Radila binti Adel Patri and today I will be presenting part of our topic on occupational noise exposure among fogging workers. For my part, I will focus on three main areas which are risk characterizations, noise risk assessment and exposure monitoring. I will first explain the level of noise that fogging workers may be exposed to. followed by how we assess the risk, and finally the methods that can be used to monitor both noise exposure and workers' hearing health. For this slide, we can see the noise risk profile associated with fogging activities. The risk of noise exposure mainly depends on two factors, which are the noise level and the duration of exposure. Thermal foggers may produce approximately 85 to 100 decibels, while ULV foggers are generally around 90 to 95 decibels. However, some reported exposure levels may reach as high as 120 decibels, which indicates a potentially serious risk to workers' hearing. The level of risk can also increase because of several factors. First is longer operating time, because the longer the worker is exposed, the greater the overall noise exposure. Second is when the machine is positioned close to the worker's body of ears. Third, operating multiple fogging machines at the same time can further increase the overall noise level. And lastly, working in narrow or enclosed spaces may increase noise because sound can be reflected from surrounding surfaces. Therefore, we cannot only look at the noise level itself. We also need to consider how long, how close, and under what conditions the worker is exposed. It is also important to remember that these values are indicative, so actual workplace exposure should be confirmed through proper field measurements. Moving on to the second slide, this shows the 5-step process of noise risk assessment, or we call it NRA. The first step is to identify the noise sources. For fogging workers, the main sources may include the fogging machines, spray equipment, and vehicle engines. The second step is to estimate the duration of exposure. Here, we need to determine how long the worker operates the machines or walk close to the noise source. The third step is to measure the actual noise exposure. This can be carried out using equipment such as a sound level meter or personal noise dosimeter, preferably measure close to the worker's ear level. The fourth step is to compare the measurement with the relevant standards. We look at measurements such as the time-weighted average or TWA, peak noise levels, and the overall risk category. Finally, the fifth step is to document the findings and introduce appropriate control measures. If the exposure is considered too high, corrective action should be implemented to reduce the worker's risk. So, in simple terms, the process is to identify the source, determine the exposure time, measure the noise, evaluate the risk, and then take the action. For this slide, I will explain the different tools that can be used for exposure monitoring. A good monitoring program should include both objective measurements and subjective information from workers. The first tool is the sound level meter, or SLM. This is mainly used for spot measurements to determine the peak and average noise levels around the worker's ear during fogging activities. The second tool is the personal dosimeter. Unlike the sound level meter, the dosimeter is normally worn by the worker throughout the working period or full shift. It continuously records the worker's noise exposure and helps calculate the time-weighted average exposure. The third method is audiometric testing. Audiometric testing is important because it establishes the worker's baseline hearing level and helps identify any changes in hearing ability before more serious or permanent hearing damage occurs. Finally, we can conduct a symptom survey. Workers can report symptoms such as ringing in the ears of tinnitus, difficulty hearing, fatigue, stress, and sleep disturbance. This is important because measurements from equipment alone may not fully show how noise exposure is affecting individual workers. Therefore, an effective noise monitoring program should combine instrument measurements, audiometrics testing, and feedback from the workers themselves. That concludes my part of the presentation. Thank you for your attention.
Good morning, everyone. Moving to health surveillance. This slide covers audiometric surveillance and follow-up. The key principle here is to detect early. The process follow three main steps. Step 1, compare hearing threshold over time. This is the best line of surveillance. We track each worker's hearing test result year by year. Step 2, identify change. Here we look to detect any threshold shift to persistent symptoms like tinnitus or speech hearing difficulty. This is the trigger point. Step 3, intervene. Once a change is detected, we take action. This includes medical referral, possible task reassignment, and a review of hearing protection. And finally, evaluate the program. We check whether the current controls are actually preventing further hearing loss. Early action. We must investigate tinnitus, speech, hearing difficulty, or any measurable threshold shift immediately. Do not wait for permanent loss. Remember, audiometric testing should always be linked to corrective action and program review. Next, we look at control measures, specifically the hierarchy of noise hazard control. The principle here is to go from most to least effective. We should always prioritize control at the source, not just rely on the worker to protect themselves. The hierarchy has three levels. First and most effective, engineering controls. This is about changing the workplace itself. Example includes installing sound barrier, using vibration dampener, and enclosing noisy equipment. Second, administrative control. The focuses on changing how people work. Example are rotating work tasks to reduce exposure time, scheduling work during low peak noise hours, and conducting safety training. Third and last, personal protective equipment or PPE. This is our final line of defense. Example includes providing earplug, earmuff, and feet canal caps. But please note the key point in the dark blue box, PPE should not replace visible source control. We use PPE only when engineering and administrative controls are not enough or while they are being implemented. In short, the goal to eliminate or reduce the noise is at the source first.
Good day to my dear lecturer and my fellow friend. I'm Sa Asfia bin Abu Bakar. Now let's move from the theory to practice with a practical control plan, starting with the engineering control, where feasible install barrier or acoustic shielding. Use vibration dampeners and insulated compartments on equipment. Maintain and lubricate moving parts to reduce mechanical noise. And when replacing equipment, select quieter models. This is a long-term investment in worker health. Administrative control include rotating tasks to limit individual exposure time, rescheduling work during lower activity period when possible, inspecting equipment before each campaign, training workers on risk procedures and reporting mechanism. For personal protection, provide correctly rated earplug or earmuff. Ensure proper fitting and consistent use through training and supervision. Inspect, clean, and replace worn device regularly. Keep kernel caps available for suitable tests. The key is to combine this control, assign responsibility to specific individual, and verify implementation during field operation. Control on paper are not control. They must be implemented and verified.
Let's review the regulatory framework that guides our approach. In Malaysia, we have the Occupational Safety and Health Noise Exposure Regulation 2019, along with those industry code for practice for management and occupational noise exposure and hearing conservation 2019. Internationally, we reference OSHA 29 CFR 1910.95 from the United States and the WHO Environmental Noise Guideline from 2018. Our priority action under this framework include: first, conduct a formal noise risk assessment for every machine and work setting. Second, establish a comprehensive hearing conservation and audiometric program. Third, track exposure, system, PPE fit, and corrective action systematically. Fourth, audit, control, and repeat measurement after improvement to verify effectiveness. I must note that regulatory titles are presented for academic discussion. Organizations should confirm the latest applicable legal requirement in their jurisdiction. In conclusion, I want to leave you with three key takeaways. First, fogging workers can face hazardous noise well above 85 decibel, the safe occupational limit. This is a real and significant hazard. Second, the risk is driven by noise level, exposure duration, and the work environment. It's not just about the machine itself. It's about how, where, and for how long workers are exposed. Third, prevention requires a comprehensive approach. Measurement, health surveillance, and layer control working together. No single measure is sufficient. And lastly, the key reference for our work include those Malaysia Industry Code for Practice for Management of Occupational Noise Exposure and Hearing Conservation 2019, WHO Environmental Noise Guideline for the European Region 2018, Yap et al. Study on Noise-Related Hearing Disorder among Vector Controls Workers in Kuala Lumpur 2023. Abdul Rahman and Ismail works on effect of noise and pesticide exposure among fogger 2030. Last but not least, I want to thank you all for your attention.